In this video, we're going to be building RayCast-based projectiles in Godot 4.2.2. So in order to make our projectiles, there are two key nodes we're going to want to put together. The first of these is a projectile launcher. This is what's going to fire our projectile in a set direction. It's going to use a timer so that it can fire on a cooldown. It's going to create those projectiles with code. It's going to tell them what direction to fire, and you're going to be able to attach this to anything you might want to fire projectiles. So for example, the camera or a turret or whatever else. And its scene tree is going to end up looking a bit like this. We're also going to need to create a projectile scene, and this is what the projectile launcher will fire. And this is going to move in a given direction and detect any collisions. So for example, if it hit an enemy, it could do damage to it, or whatever else you might want the projectile to do. When the projectile collides, we're going to make it stop moving, and if it stops moving and it hit a body that can move, we're going to attach the projectile to it and make it so it moves independently of its parent. The important thing about attaching it to a body means if you shoot something like an arrow, and for example it hits a moving platform, if the arrow just stays where it is and doesn't move with the platform, it's going to look really odd. So it's useful to know ways that you can make these objects attach to an object that they've hit. And the projectile is going to look something a bit like this, with a RayCast node, a mesh instance, and a timer of its own for cleaning itself up. So because the projectile launcher needs a projectile in order to work, it makes sense to start by making the projectile. We're going to create a new scene with a RayCast3D as the root node. And a RayCast3D is a node that casts a ray in a given direction, and it lets us know what the first body it's encountered in that direction is. This projectile is going to need a mesh in order for us to be able to see it in-game. So we're going to need to add a mesh instance 3D as a child. If you've made something like an arrow model GLB file, you could use that in place of the mesh. I'm just going to be using a cone as a convenient built-in shape. We're going to want to add a timer as a child of this RayCast3D, and what that timer is going to do is it's going to delete the projectile after a set amount of time. If you don't have some kind of cleanup like this, there is no limit to how many times the player can shoot, so they could just keep adding raycasts to the scene until eventually you run into memory issues. So having cleanup like this is very helpful. After that, we're going to add a script onto this projectile that moves it every frame, and it's going to need to have the top level property enabled so that it ignores its parent's rotation and position, and so that it can move on its own. Alright, that's enough talking, let's go ahead and set up the scene. So I have a project that I'm starting from, which is built off of the Godot character controller you can get from GameDevTV, but it's been filled out with all my own assets and shaders and the like. So we are going to be adding a projectile that this character can fire, and as I was saying, we're going to create a projectile scene, so let's create a new scene. I'm going to click the plus button at the top of the viewport to create a new scene, and I'm going to select the root node of this scene to be a RayCast3D. So in the scene tree on the left, I'm going to click the other node option, and in there I am going to search for RayCast3D as the root node, and double click on that, and now we have a scene where a RayCast3D is the root node. So this RayCast3D, it's going to need a mesh instance, a timer, and we're going to need to set up some of its properties. So let's add a mesh instance to start with. I'm going to select the RayCast3D, and I'm going to rename it to Projectile. And then I'm going to hit Ctrl and A to add a child node, and this child node is going to be a mesh instance 3D, and you can see it there. And this is, as I was saying, just a placeholder. I'm going to use a cone as our projectile mesh. So with the mesh instance 3D selected in the scene tree, over in the inspector on the right, I'm going to click the drop down to the right of the mesh property, and I am going to select a new cylinder mesh, because we can turn a cylinder into a cone. If you click on that cylinder mesh, it'll expand all of its local properties that will let us customize its appearance, and you can see it's got a top radius and a bottom radius. Now because we can customize these radiuses, we can turn it into a cone. I'm going to set the top radius to be 0 meters, so it is a point with no width at the top, thus making us a cone. I'm going to change the height of this cone to be 1 meter, because 2 meters is quite long, and I'm going to set the bottom radius to be 0.1 meters, so we have a rather thin point. Now I'm going to collapse that mesh, that's customized enough, but I'm going to go down to the transform property, and what I'm going to do is I'm going to rotate this mesh so it's pointing in the positive Z direction. Editing Bram here. I made a fairly typical mistake here, and that's the forward vector points in the negative z direction. So we actually want it to point in the opposite way to what I'm showing. I am going to correct this later on, but just so that you can keep up, the transform should be set to negative 90 on the x rotation rather than positive 90. And the positive z direction is the direction this blue arrow is pointing. And we can get that by rotating it along the x-axis to 90 degrees. And we will have our projectile cone that is pointing in the direction we're going to be shooting. Now we have our mesh, we can also add our timer. So I'm going to select the root node, I'm going to hit Control and A, and I'm going to search for a timer node, and I'm going to add a timer to the scene. Now this timer has a couple of properties we're going to need to set up. The timer is going to be one shot. That means the timer is going to run just once, and then when it's finished, we will clean up this projectile. We also want to enable auto start because when we create the projectile, that's the moment we want this timer to start so that we can then delete it after it's been in the scene for too long. We're also going to want to pick a wait time here. This is how long our projectiles are going to be in the scene before they get deleted. I think 30 seconds should be plenty of time for us. Now that that's all set up, let's return to our projectile root node. And one thing I want to do is go down to the transform foldout menu. And in the transform foldout menu, I want to enable the top level property. What this means is that this node will not inherit the transforms of its parent. So if the player creates this projectile and the player walks around, the projectile won't move when the player does. This will have its own transform that moves globally. So now this is all done, I'm going to go ahead and save this scene. So I'm going to hit Control and S, and I'm going to find an appropriate place to put my projectile. I'm going to just create a new folder for all my projectile stuff. So I'm going to create a folder in my root node. I'm going to call it Projectile, hit Enter, and I'm going to save projectile.scene in here. Now it's saved, we can attach a script, which is going to be responsible for moving the projectile and cleaning it up and all that good stuff. So I'm going to right-click on the projectile root node and attach a script. We don't want a template script, so if yours looks like this, that should all be good, and we can just click Create. And now we have our projectile and a script, let's talk a little bit about what a RayCast node can do. So a RayCast node fires a ray in 3D space, and it can check if there's any objects in the way of that ray, and tell us any intersections that happen along its path. It has a bunch of properties that control what the ray can collide with. So we can set its collision layer, and that will only hit objects that are in the same collision layer. We can also add exceptions with a script, so we can make sure that the ray, for example, can't collide with our player. There are also properties in the inspector that will let you make it only collide with areas or bodies or neither. The RayCast has a target position property. This is where the ray is drawing to. So the ray starts wherever its transform position is, and it draws the ray to this target position. And then we can use a script to check if there are any collisions on that path. We need to call a force RayCast update function, and that checks for any collisions from the origin to the target position. And then after we've done that, we can use some functions like isColliding, getCollisionPoint, and getCollider. And these tell us useful things like, are we colliding with anything? What is the position of the collision that's occurred, and what is the object that the RayCast is colliding with. So with that done, we then need to start moving our projectile in the right direction. When we spawn the projectile, we're going to give it the transform 3D of the projectile launcher, so it's going to face the same way as the launcher. Our script is then going to need the projectile to move forward from its perspective. You can find out what way an object thinks is forward from its perspective with its basis. The global basis of the projectile tells us what way it thinks is forward when you combine it with a forward vector. And a basis is a matrix that stores a bunch of useful information like an object's rotation and scale, and it's a part of its transform. So we can add this line of code, global basis times vector 3.forward, and we will get a vector pointing forwards from the ray's perspective. And we're going to want to use that to move our projectile in this direction every frame. So let's go ahead and set up that script. I'm going to enter distraction-free mode, so I've got a bit more space. You can do that by hitting Ctrl-Shift-F11, or by clicking this little expand or minimize button at the top of the viewport. The first thing I'm going to do is I'm going to define an exported variable that's going to tell us how quickly the ray moves. And I'm going to do that with an export variable. So I'm going to say @export var speed colon equals 50.0. Now you might not be used to colon equals. I like to use static typing. That's where you tell Godot the type of the variables you're using. And you usually do that with a colon, for example, saying colon float, and then you set your value to be equal to something. This is optional, you don't have to do it, but Godot will run better if you define the types of your variables. So I recommend using it when you can. And if you use the colon equals symbol, it will guess the type of this variable from whatever value you're assigning it to. So because there's a 0.0 here, it can guess that speed should be a float. So this speed is going to be how fast our projectile moves every frame. So it's going to be moving 50 units a second. With that done, we're going to want to add our function that moves our projectile, and that's going to be a physics process function. So just below that, I'm going to say func_physics process, and I'm going to hit enter. Now, same point about static typing, yours might not have colon float and a return type at the end of it. If you want to enable static typing by default, you can go to the top bar, click the editor button, go to editor settings, and you can search for type hint. And under the completion option, you'll see there's an add type hints option. And when you have that enabled, it adds those type hints by default. As I said, they're optional. You don't necessarily need them, but I recommend them. I'm going to close this and return back to this physics process function. What this is going to do is it's going to move our projectile in the direction it's facing every frame. So the way we're going to do that, I was saying you can get the direction that the projectile thinks is forward by saying global basis times vector3.forward. So that is the direction that this projectile thinks is forward, the way the cone is pointing. What we're going to want to do is we're going to want to add this onto our position. So I'm going to say position plus equals that forward direction. And then I'm also going to multiply it by our speed. And then lastly, I'm going to multiply by delta. Delta being the elapsed time this frame. So by multiplying by delta, it's going to turn this speed into a number of units per second, rather than making the motion frame rate dependent. But in short, this line of code is how we're going to be moving our projectile forwards at 50 meters per second. So that's just the position. We're also going to want to set the target position of our projectile, and we're going to do that just with a vector3.forward. So I'm going to say target position, which is a property of a RayCast3D. I'm going to set that to be equal to vector3.forward, and that's 1 meter in front of us. We want to check this distance in front of us, so how far we're trying to move, to make sure our ray is cast to every point our ray is trying to travel through. So I'm going to set the target position to be equal to vector3.forward times speed times delta. But now you should see that every frame, our raycast will draw a line forward, check if it collides with anything in that area, and then if it doesn't, it will carry on and move to the end, and then it will redraw that distance again, and it will check if there's any obstacles in the way, and then it will move past it again, until eventually it finds something and collides with it. So as I was saying, the raycast won't update until we manually update it, so we need to call a function called force raycast update. So now, in this frame, it's moved, it's updated its target position, and now it's checked if there was anything to collide with between where the ray is and where it's pointing, and now all of its other functions will be updated to reflect whatever the raycast update found. So we can define a new variable, var collider, and I'm going to set that to be equal to getCollider. So if our ray has found a collision on its path, the body or area that it's collided with is going to be saved in this variable. Now, below that, we can check if we are colliding. So I'm going to say if is colliding, which is updated when we call the force raycast update function. If we are colliding, I want to set the position of our ray to be the position the collision happened at. So as it's moving along, when it finds its eventual target, it snaps to the point where it should collide with the geometry. So I'm going to say global position equals get collision point, because get collision point returns a global position for us. So now when we collide, we will snap to that final point we collide with. Just after that, I want to do a bit of a neat trick, which is I'm going to say set physics process false. Set physics process determines whether or not this physics process function is running. By stopping the physics process function running, we will stop trying to move the raycast. So when our ray eventually hits some geometry, it will then stop moving after it finds its final position. I now want to do one extra thing, which is I want to, on a new line below, I want to declare a new function. I'm going to call this cleanup. This is the function that's going to get called when our timer runs out. So when we try to delete our projectile, we might use it for other things later on. But what this is just going to do is queue free the projectile. So when our timer runs out, the whole projectile gets deleted. So now we need to connect our timer to this cleanup function. So I'm going to save this. I'm going to exit distraction-free mode. I'm going to go to the timer. I'm going to look over to the inspector, and I'm going to change over to the node tab so I can see the signals of this timer. And I'm going to select the timeout signal of the timer, and I'm going to click the connect button in the bottom right. Now I can connect when this timer's finished to that cleanup function. And we can pick it directly in this connector signal to a method dialog. We can click the pick button in the bottom right to pick a function to connect to. So I'm going to click pick, and I'm going to pick the cleanup function I just defined. And now I can click OK. And we can click connect to actually set up this connection. And we should now find that there is a little arrow next to the cleanup function indicating that a signal is connected to this function. And if we click on this little signal icon next to the timer, it'll take us over to the signal tab, and we can see timeout is connected to the cleanup function. So with that done, we have a projectile that's going to move in a direction every frame. And actually, we can show it off right now. I'm going to change over to my test level. You can add this to any level you've set up with a camera that can see it moving, but I'm just going to instantiate a projectile. So I'm going to hit Control-Shift-A to instantiate a scene. I'm going to search for projectile, and then I'm going to add a projectile to my level. So this is a projectile that hasn't been launched by the launcher we're going to make, but it will show us that the projectiles are working as we're intended. So I'm going to find that projectile, and I'm going to move it somewhere useful. There we are. Editing Bram again. This is the point where I realised that the transform for my projectile is wrong, and I set it appropriately to -90 on the x-axis rather than +90. Now things should be back to normal from here on. So let's reposition this projectile. In fact, actually, let's just point this at the house so that we can see it going towards something. There we are. I have a projectile. It's going to move towards this house until it eventually collides. Let's see that in action. There's the projectile moving. Let's see it get stuck in the geometry of the house when it eventually collides. There we go. So the projectile keeps going until it hits the wall, and then it stays there. And we should find if 30 seconds elapse, this eventually deletes itself. And it got deleted. There we go. All right, on to the next step. So we've made our projectile, we can fire it in a direction. Now we need to make our projectile launcher. This is going to be a node 3D, and we're going to be able to add it to any object we want to fire a projectile in a given direction. For an FPS, it's ideal to attach this to the camera, or in a towered fence you could add it to a turret. Whatever you need, you'll be able to launch projectiles with this node. The launcher needs a timer that's going to restrict how frequently it can fire. If you don't have something like this, you'll be adding just tons of projectiles. Say you have it triggered to fire as you hold down the mouse, you'll be firing them every frame and it'll get very out of hand. So we're going to add a timer that restricts how frequently it can fire, and tweaking this timer will control the cooldown in between shots. So we're going to be adding a script to the projectile launcher that can instantiate and orient the projectiles to face the right way. And we can actually get rid of this projectile now, we're not going to need it anymore. Let's save this test level, I'm going to go back to the projectile, and actually we want to create a new scene that is our projectile launcher. I'm going to click the plus button at the top of the viewport to add a new scene, and I'm going to set the root node of this scene to be a 3D scene from the scene tree on the left. I'm going to rename this node, I'm going to call it Projectile Launcher. And now it's got a name, I can save it in the projectile folder. So I'm going to hit Control and S, and I'm going to save it in the projectile folder. You can see it's been named the same name as I gave that node, which is one of the main reasons I rename the root node immediately. But I'm going to save Projectile Launcher in here. This is going to need a timer, so I'm going to hit Control and A, add a timer, and hit Enter. This timer is going to be one shot, so enable the one shot property. That means when we shoot, it'll fire once, and the timer won't keep counting down afterwards. We will know when the timer has finished for our cooldown between shots. And now we can attach a script to our projectile launcher. So I'm going to right click on the projectile launcher node and click attach script. And all of these options are fine. And I'm going to click create. So the first important thing is we want to instantiate our projectile. So we're going to need a reference to the projectile scene. And we can generate that by finding the projectile in our file system. So if you look in the bottom left of the file system, if you search for that projectile scene, so projectile, and you find projectile.scene, if you hold Control and drag projectile into the script, you'll see that it creates a constant projectile node for us. We're also going to want a reference to our timer. So below that constant projectile, I'm going to look over to the scene tree. I'm going to make sure nothing's selected. I did that by holding Control and clicking on the timer to unselect it. So it should be empty like this. And I'm going to drag that timer into our script. So we get an onReady variable for our timer. So now we have a reference to our projectile scene and we have our timer. We can do a bit of coding. I'm going to enter distraction-free mode, and I'm going to add a physics process function to this projectile launcher. Unc_physics process. In here, we want to fire a projectile if our timer is off its cooldown. So if we have cooldown between shots. The way we can check if we're off cooldown is we can use the timer's isStopped function. So every frame, if timer.isStopped. So if our timer has finished cooling down, then we can try and fire a projectile. We're going to want an action now for firing our projectile. You could bind this to the spacebar or clicking or buttons. I've bound a click action. I'm just going to show you the input map quickly. If you look in the top bar, go to the project button, click on that, go to project settings. You should see in project settings, their second tab from the left to the right of general is input map. And in input map, you can define all your own actions. If you don't have one for shooting, you can add it by selecting the add new action field at the top, and you can add an action called shoot, for example. We'll add a shoot action to your input map at the bottom here, and you can, for example, click the plus button to the right of it and bind that to a left click event. I have an event called click that's bound to a left click that I'm going to listen to. So I'm going to close that. So I'm going to use the action I just showed you and check for if that action is pressed. You could also use UI accept if you want to use a built-in one. But if input.isAction, and now there's a distinction here. There's either just pressed or pressed. Just pressed will only trigger when you push the key down. If you want it to fire while the key is held down, you want action pressed. If you want it to only fire when you click, then you want just pressed. So the difference between semi and fully automatic. But I'm going to go with is action pressed so that if I hold down the click button, it will continuously fire. So is action pressed, and then I'm going to listen for the click action that's in my input map. Add a colon, and then in here. So if we're off cooldown, and if we've clicked the shoot button, we want to fire the weapon. First of all, I'm going to start the timer here, timer.start. So now, every time you shoot, the timer restarts and you can't shoot again until the timer's finished. We can set a cooldown time in here, for example 0.1 seconds, and now we will only be able to fire 10 times a second at most. So now we need to instantiate our projectile with the instantiate function. So I'm going to say var attack, and I'm going to instantiate the projectile scene. The way we do that is by taking our projectile preloaded value, and I'm going to call its instantiate function. And what this will do is it will create that scene that we can add into the scene tree. So now we have a projectile scene. I want to add it as a child of our projectile launcher. So I'm going to say add child, and I'm going to pass in that instantiated scene. And now the last thing I want to do is set the projectile to be oriented the same way the launcher is. So for example, if the launcher was on the camera, the projectile would fire the same way the camera is facing. And the way we do that is I'm going to say attack.globalTransform, and I'm going to set that to have the global transform of this node. So I'm going to say equals global transform. And that should be everything we need. So let's try adding this projectile launcher into our game. I'm going to exit distraction-free mode. I'm going to go back to my test level. In fact, I'm going to go ahead and find my player scene. So I'm going to hit Control-Shift-O is the quick open scene search. And I'm going to search for my player. and I'm going to hit enter. And now in my player scene, I want to attach that projectile launcher to my camera. So I'm going to search for a camera 3D in the scene tree. I'm going to find my main camera, which is this one called Smooth Camera. I'm going to hit Control-Shift-A to instantiate a scene, and I'm going to instantiate the projectile launcher we just added. So now we should find there is a projectile launcher here, and that should be everything set up. If I run the scene now, and I go ahead and I look in a direction, and I click, it should fire projectiles at 50 meters a second forward, and they get stuck into whatever we shoot at, which is really nice and works pretty much as we expected. So that's it for firing projectiles. This is the minimum bare bones version of this effect, but there are edge cases I want to clean up because I think they're important. So one thing I brought up earlier is it's important to figure out what happens if one of our projectiles hits a moving body. So I've just put together a little example to show this off. I've added this barrel. It is an animatable body 3D, so it is physics enabled and it is moving. We should find that if, for example, I were to somehow stand on it, I move with the body as it rotates. But this has the problem. If we go ahead and shoot this with some of our projectiles stop moving when they hit the target and they stay still, which looks all wrong. These should move with that animatable body. So we're going to need to do some extra steps if we want to make these raycasts move with a moving object, for example, like a enemy character rig if we want it to move along with them. So the way we're going to tackle that is we're going to use the RemoteTransform3D node. This is a really handy node for a lot of different things, and what it's essentially responsible for is it passes the transform that it has onto another node. So the position, the scale, and rotation of the Transform 3D gets sent onto something else, and then that is made to have the same transform. What we want to do is in our projectile, we want to add a RemoteTransform3D as a child of the body we've collided with. So for example, that animated barrel. We also want to add it at the position the collision happened, and then we can make that RemoteTransform share its position back onto the projectile. And then we should find the RemoteTransform3D will move with the animatable body, and that position will get shared back to the projectile, and it'll all just work. So in order to make the RemoteTransform3D be able to update the projectile, we're going to need to find the path from that other node to the projectile. But thankfully there is a built-in function that's going to do that for us, because the RemoteTransform uses a remote path property to figure out what node it should update the transform of. So what we can do is we can use the getPath2 function to figure out the path from the transform to our projectile. So with that all in mind, let's get back to our projectile script. So I'm going to hit Control-Shift-O to quick open a scene. I'm going to search for projectile. I'm going to open the Projectile Scene directly because this has the script we're going to want to change. So I'm going to go to the script. I could have used Control-Alt-O to search for a script rather than a scene, but looks like I missed that. So what I'm going to want to do in here is I'm going to want to create a remote transform, and then after we collide, add a remote transform onto the body we collided with. So I'm going to define my remote transform. So just below where we define the speed, I'm going to create an onReady variable at onReady bar, and I'm going to call this remote transform. And I'm going to set this to be equal to a new remote transform. So colon equals RemoteTransform3D.new. And that is going to create a RemoteTransform3D node, but it's not going to add it into the scene tree as a child. It is just in memory ready for us to use. So now, in our physics process function, after we set physics process to false, what we can do is we can go ahead and we can find the collider that we saved in this collider variable. We can go ahead and get that collider, and we can give it a child. We can do collider.addChild, and we can give it the remote transform that we've created just for this purpose. I spelled collider with 3 L's. There we go. So now we have a remote transform as a child of whatever object we have collided with. But as I was saying, the RemoteTransform3D has a remote path that tells us the path to the node we want it to update. So what we can do is we can take that remote transform, we can set its remote path property, so .remote path, There we go. And we can set that to be equal to, and then we can find the path from this remote transform to this projectile node. So remote transform dot get path to, and then we can pass in self. And now that remote transform has the path to this projectile and will update the position of this node. One last step I missed here is we need to make sure the remote transform has the same global position that this node does at the time of the collision. So I'm going to say remote transform just after we add it as a child of the collider. We want to set that to have the same transform as this projectile. So remote transform.global transform, and I'm going to set that to be equal to the global transform of this projectile. We should now find, if I run the scene and I go back to the barrel, that as I shoot the barrel, our projectiles get stuck in and they rotate with it. Isn't that glorious? So that's all well and good, but what happens if, for example, we fire all these projectiles into an animatable body, or an enemy, or whatever else, and then that body gets deleted? Well, if I hit the end button at the moment, this thing's going to get deleted, so let's see. All of those projectiles are still there at that position. So if a body with a remote transform gets deleted, the body will just remain there because the projectile doesn't know that the remote transform's parent got deleted. We want to also delete the projectile if the remote transform disappears. Now, thankfully, there is a signal that can get us out of this mess. All nodes have a tree exited signal that tells us when it's leaving the scene tree after deletion. So if we listen to that signal, we can delete the projectile at the right time. So what we're going to want to do is we're going to want to get the remote transform's tree exited signal and also connect it to that cleanup function. I'm going to go back to the projectile script, Control-Alt-O, remembered this time, projectile.gd, enter distraction-free mode. So now, after all of this stuff, setting up that remote transform, we're going to just want to add one more line. We're going to say remote transform, and we're going to get its tree exited signal, so dot tree exited, and we can connect a signal to a function with the connect function. So we're going to say dot connect, so connect is being called on this tree exited signal, and callable is the function we want to connect it to. And we just want to also connect that to our cleanup function. So I'm just going to add cleanup there. And now we should find it all works. I'm going to run the project. I've got my projectiles, I can fire as many as I want, and if I shoot them at a moving body, thanks to the remote transforms, they move with the moving body. And then lastly, if we delete that body, all of the projectiles get deleted with it. And there we have it. That's everything I'm going to say about projectiles today. There is other stuff you might be interested in that I didn't think was directly relevant. If you wanted to have the projectiles handle different types of objects they collide with, you might want to do some type checking. You might want to say something like, if the collider is an enemy, then make the enemy take damage, or whatever else. But this is all of the setup you need and all of the fiddly stuff you might not have thought about that will make all of your projectiles more robust and cool. So that's it from me. I've been Bram. This has been your Godot tutorial for the day. Thanks for watching, and hopefully I see you in the next one.